We load it onto the dip lorry and truck it out to the shore in the workshop, as the workshop was established on the shore. Then there the corroded flange, top flange was cut and new flange was fixed. Then this photo shows insertion of the repaired rail stringers. These are some of the other photographs of the bridge. Other thing which we did was rectification of tilted bearings. So bearings had got tilted, I should say rather inappropriately. So restriction was going on at the rate of 45 kmph on the same bridge. We took, we got it designed from Messrs. Stoop of Calcutta, and then traffic blocks, rail and road were taken for 3 hours. And on 2 days, that is on 7th and 12th of January, we completed this work. This is the photo of the tilted bearing. This is what after replacement we did it. I'll show a small clip. It's around 2 minutes.
East to the west of India. Saraighat main cargo bridge built over Brahmaputra River near Guwahati provided this vital connectivity in 1963. This bridge has been standing firm over mighty Brahmaputra for the past 55 years. This has been possible because of hard work and maintenance skills of railway engineers in spite of vagaries of nature and numerous earthquakes that keep occurring in this part of the country. It was probably because of 6.1 on Richter scale earthquake of 21st September 2009 that the bearings undergo and girders got tilted. While this was not considered unsafe, the bearings in fact needed proper rectifications. The bridge was kept under observation and speed of trains was kept at 45 kmph. Rectification of bearings was indeed a herculean task, as ends of the bridge girders were to be lifted by about 10 centimeters. Such work has never been taken up earlier. After thorough research and design, the engineers decided that the lifted bearings of this bridge would be rectified. Accordingly, necessary preparations were made to deal with all kinds of possible adverse situations that could occur so as to avoid disruption to this vital connectivity. Request. Bearing members were arranged and heavy-duty lifting jacks of 500-ton capacity apart from other machinery were mobilized to rectify the bearings without any hazard. The rail and road traffic on the bridge was suspended temporarily for 3 hours on 7th and 12th January 2018. Hydraulic and mechanical jacks were installed under the railway girders. With the help of these jacks, the railway girders were lifted as required. The bearings were removed from their place and installed back to correct inclination after cleaning, etc. After ensuring correct position of the bearings, the bridge girders were lowered back to original position. Road surface was brought back to original level. Rail track was also refaced and regular rail and road traffic movement was permitted within 3 hours on both days.
We observed it for about a week. Then we realized the speed from 45 to 60. Then after 1 week gap, we relaxed it to 75, which is the sectional speed of that section. Thank you.
Thank you, Mr. Mohanlal, for this interesting presentation. In fact, we will have to do a similar work in Yogigopa, respacing of the stringers for the double line. The next presentation is construction and launching of a prestressed concrete box girder in a curved profile by Sandeep Kumar Saad, Divisional Engineer.
Good afternoon, sir. My topic of presentation is construction and launching of prestressed concrete box cutter in a curved profile, a learning experience. Box cutter bridge is the bridge where the main beam comprises of the shape of hollow box. It can be constructed of prestressed structural steel or the composite steel or and reinforcement concrete. My project itinerary is detail is the client was Calcutta Metro Rail and the contractor was Simplex Concrete Pipes Limited. The construction is done for the 125 piers and 124 ballastless prestressed concrete box girder. The main challenge of this construction of this prestressed concrete box cutter is it has to be constructed in already elevated or the already constructed substructure of the trestle and above the piers, and it has to be laid in the curved profile. These are the structural components, and the structural components comprise of substructure and the superstructures. Substructures were foundation and piers, and the superstructure were two types of girders, cast in situ girders and the precast concrete box girder. Out of total 124 girders, 36 numbers girders were cast in situ, and the 88 numbers of girders were the precast box girder. And out of the 88 numbers precast box girder, 68 numbers are 20 meter span, and the 20 numbers are the 25 meter span. All the precast box girder has to be fixed and maintained in a predetermined horizontal curved profile. These are the design criteria, and the code are followed at the several Indian standard concrete bridge code, and with all correction slips, IRS bridge rules, and the IS 16268 and 1786. Design was done for the severe exposure condition, and the loading standard taken as the axial load metro RTS coaches, and this design was suitable for the track for the curve up to the radius of 200 meter. Alignment of the track is taken as, up to the 100 mm. These are the different construction processes. The first construction process was the staging, and these are the pictorial diagram of staging of the different component of the box girder. For the web and the soffit slab, the height of the staging is taken as a 1.3 meter, and the vertical pipe were taken for the staging, which having diameter 50 mm. And this for the soffit slab, vertical pipe height was 1 meter. And for the staging of the deck slab, this the height was 1.15 mm. These are the different shuttering plate used for this shuttering. For the state plate, we have taken 3 mm plate, which have the area of 1.2 into 0.6 mm meter square, and 1.25 into 0.55 meter square plate. And this 3 mm thick plates were attached with the ice angle 50, and wherever the requirement is there, the car plate is taken as per the same. These are the reinforcement was taken for this box girder construction, and this TMT bar, high steel deform bar, and the corrosion resistant steel bar was used for that. Grade of steel was taken as a...
Just excuse me, please don't read out. These things are there, the routine things. Please go on to the main part.
Okay. This bar are used are 8 to 25 mm, and the minimum lap length used is 35 D. This soffit slab reinforcement, this soffit slab reinforcement 10.5 and 25 reinforcement used as a longitudinal bar, and the middle of the girder 2 extra reinforcement is used. These are the pictorial diagram for the deck slab and the wave reinforcement. 10 to 25 meter bar are used, and for this wave reinforcement, the vertical stirrup uses 150 center to center. Casting grader box girder is M45, and the admixture used are the this rebuilt 850. It is used to delay the this initial setting time of the this complete mixture, and added as a 0.7% of the weight of the concrete. After the this casting is done, the transportation of the concrete is done by the from the nearby batching plant with the help of the transit mixture. The capacity of this quality this batching plant is 30 meter cube per hour, and this after the transportation of the concrete, compaction is done. Pre-stressing, this pre-stressing is done in different stages. This 12 number for the 20 meter span, and the 76 mm for the 20 meter span. These are the 11 number of duets are used for that. This 8 for the design and the 2 for the future. After that, different stages, pre-stressing was done. 1 and 4 for the 7 days, and the 14 days, after the 14 days of the casting of slab, number 2 of the duet. After that, the grouting is done by the grouting pump. The admixture used is XMC. This is having the non-sinkage property. And this it is done by the injection of the grouting pump. 5 kg per centimeter squared is the pressure of this. After that, launching is done. Launching is done by the this launching girder, and this counterweight used for that. Counterweight capacity is 2 number 100 ton capacity crab are used for that. And this for the launching this temporary arrangement was done in the already constructed pier, and this by the side jacking or the side shifting of the jack, the side shift of the girder with the help of side jacks. This launching is completed, and then the launching girder is shifted to the next pier where the launching is to done. Finally, this pre-stressed girder is lowered by the winches, and it is shifted to the exact bearing locations. In that way, total the casting and the launching of the pre-stressed girder is completed. Thank you.
Thank you very much. The next presentation is on restoration of breached bridge, approaches of bridge number 133 in New Jalpaiguri Malda Town section of Katiyar division by Shri Rajveer, Senior DN Coordination, Katiyar.
Good evening to all. I will be giving a brief presentation on restoration work
done by Katiyar Division, NFR, on bridge approaches of bridge number 133 in New Jalpaiguri Malda Town section. This bridge was occurred in the month of August 2017 when there was a heavy rainfall in the foothills of Himalayas in Nepal and adjoining area of the Bihar. There was 19 districts affected due to this bridge. 17.1 million people were affected. About 56 teams of NDRF, SDRF and army personnel were deployed for the rescue operations. It leads to 514 deaths. There was heavy loss to the life and properties, and it resulted breaches of embankments, bridge approaches and burst outs in Katiyar Division. There were total 58 locations in the Katiyar Division which were affected due to this heavy floods. This is the table showing the major bridge locations. There were 5 locations in the New Jalpaiguri Malda Town section, which is V route and is connecting to the entire northeastern states. There were 3 minor bridge washouts, completely washouts. There were embankment of 1.14 kilometer washing out in Katiyar Joguni section. Similarly, in Ikalke Balughat section, about 0.7 kilometer section was washed out. This means connectivity, railway connectivity in entire Katiyar division was disrupted during this flood. This is the map showing the location of major bridge locations. You can see this in Malda town to New Jalpaiguri section, there were 5 locations which were breached out. To restore this bridge number 133 was the biggest challenge before the railway engineers, because the states in the northeastern states were severely affected by the floods, and this was a strategic location in map of India also. In the diagram below, you can see that there was a scour up to 11.3 meter, which was measured after 2 days of heavy flood. It means there was a big ditch was formed on the bridge approach. Filling of this ditch and arranging the restoration material was really a big challenge at the time. So, the restoration plan was made. In phase 1, it was decided that the section will be opened first for goods train so that the restoration material can be carried out to the side from both the directions and can be directly unloaded at the location. Work was started on 16/8/2017, and filling of boulders was started, and it was decided that we will use the CC clip in 5 layers on the prepared boulder base. Work was executed round the clock. Pontoon bridge was also constructed with the help of army so that the boulder from the other side can also be dumped on the location. And trial for goods for locomotive was conducted on 28/8/17, means just after 14 days of bridge occurred, and track fit was given for goods train on 29/8/2017. Thereafter, the top layer of the CC clip was removed, and the hollow space between the CC clips was filled up with the stone dust and sand. On both sides of the CC clip, boulder crates were placed, sandbags were placed, so that the minimum material can be utilized to prepare the embankment. And track fit for the passenger train was given on 29/8/17, just after 18 days of the bridge occurred. Initially, it was projected that it will take about 20 days, so 2 days before target, it was completed. So this is the phase 1 and phase 2. Phase 1 first diagram shows that when the track fit was given for the goods traffic, and the second phase shows when the track was made fit for the passenger traffic. A top layer of CC clip was removed and the entire hollow space was filled up with the stone dust. For the restoration of downline also, CC clips on the both sides of the prepared boulder base were erected, and then stone dust and sandbags were filled up in the between. This is the final profile which was achieved after completion of the restoration work. One is for upline and second one is for downline. These were the machineries deployed at the site. 13 poclanes were engaged, 4 number JCBs, 2 number hydras, dumpers, boulders, about 590 wagon boulders were arranged and dumped on the site. About 85,000 sandbags were used, 550 numbers of CC clips were used in this restoration work. 54 wagons of stone dust and sand was used. A challenge is faced. During this restoration work, the biggest challenge was to initially arrange manpower and machinery, because there was no road connectivity, there was no railway connectivity. Entire area was flooded with the water, so even manpower was not available for starting the work. So all the situations were worst. Somehow the labor was arranged by boats also to the site. There was total communication failure. There was no mobile working, no telephone was working. Railway telephone were also washed out. Cables were also washed out. So there was challenge to start the work as well as to execute the work. 2 tower wagons, arrangement of push trolleys, motor trolleys to carry the site. Similar to the other site, CCTV camera were also installed at this site also, and feed was given directly to GM chamber, PC chamber, and the division to monitor the work round the clock. As this bridge gives the lesson to us that there is, in case of the severe floods, there is a need to have more passes across the track. So a study was made and it was seen that the more number of bridges are required to be constructed. So work has already been sanctioned during this book. 11 numbers new RCC bridge will be constructed, 1.6 meter span in 84 kilometer of patches, which is more likely to affect in future also. The existing bridge of bridge number 133, 3 into 12.2 meter, will be replaced by 6 into 18.3 meter. 30 cm boulder is being planned to kept on all important locations, important bridges and major bridges, so that this material is immediately available whenever it is required. A strengthening of major bridge approaches is also being planned, and better coordination with the meteorological and flood control department is to be done to avoid future. One video clip I want to show of 3 minutes only. Video explain. Voice.
Between 12th and 16th August 2017, heavy to very heavy rainfall in sub-Himalayan regions of Nepal. Between 12th and 16th August 2017, heavy to very heavy rainfall in sub-Himalayan regions of Nepal caused unprecedented floods all over Katihar division of NF Railway. The scale and the magnitude of the flood was such that surging waters affected railway track, embankments, and bridges at as many as 58 locations. Approaches of bridge number 133, MK8, MK9 and MK11 in New Jalpaiguri Malda section were washed out. Bridge number 3 in Katihar Kumaitpur, bridge number 60 in Katihar Jokmani were completely washed out, which resulted in rail connectivity of the whole